Dear students, in this session we will discuss linear grammars. Okay, so first of all we'll look at the definition of the linear grammars. So a CFG, a context-free grammar that has at most one variable in right-hand side of each of its production is called linear grammar. So what property these linear grammars should have? There should be only one variable on the right hand side of each production of the grammar. So just for example, we are taking the first example. Our grammar is S to A S B oblique epsilon. So this in this grammar, we have two productions. One is S to A S B, where we are having only one variable on the right hand side. Obviously, on the left hand side there will be one variable because it is a CFG. On the right hand side there is no restriction in CFG, but these linear grammars restrict that there should be only one variable on the right hand side. So here we are having one terminal, and one variable. Okay, so two terminals and one variable. So there is no restriction on the number of terminals, but number of variables should be only one. Okay, the second production is S2 null. So here we do not have any variable on the right hand side. Okay, so as per our definition, at most one variable. So either there is no variable or there is a single variable. So all the productions of this grammar follows this rule. So that's why this grammar, such grammar is called a linear grammar. Obviously, we know the language of this grammar is a to the power I, b to the power I greater than equal to 0. Okay. Take the second example. In this example also, we are having four productions. Okay, S to AS. On the right hand side, we are having only one variable. S to BS. On the right hand side, we are having only one variable. S to A, we do not have any variable. S to B, we do not have any variable. We have only the terminals here. Okay, so in all the productions on the right hand side, there is at most one variable. So as per the definition, this is also a linear grammar. And the language corresponding to it, we can simply understand it is A plus B plus. Okay, so it is a positive closure of set AB. Okay, so regular expression is A plus B asterisk. So this is the basic definition of linear grammars. Now there are two special types of linear grammars. First one is called left linear grammar. So a linear grammar is called left linear when the variable on the right hand side, if present, will be the leftmost symbol. Meaning that because the grammar is a linear grammar, so there will be only one variable on the right hand side. If that variable or there is no variable on the right hand side. If the variable is present, so that variable should be the leftmost symbol in that particular production. If this rule is followed for all the productions of the grammar, then the grammar is called left linear grammar. It is not that it is true for only one production or two productions. It should be true for all the productions in the grammar. Then the grammar is called left linear grammar. In other words, we can understand that in such grammar, productions will be of the form either V1 to V2 alpha or of the form V1 to alpha. Means V1 means variable on the left hand side. Then the only variable present should be on the left as the leftmost symbol on the right hand side. So on the right hand side, it is the leftmost symbol. And after this, some alpha is coming. What this alpha is? This alpha is nothing but the sigma star. Sigma star means it is a string of terminals only. So only the terminals can come. So the only variable present is present as the leftmost symbol here. Or the productions are of the form V1 to alpha. So here alpha is the string of terminals only, means there does not exist any variable on the right hand side. Obviously, because on the right hand side either there is no variable or there is a single variable. So the grammar is linear. But wherever the single variable is present, it is present as the leftmost symbol of the production. So that's why the grammar is called the left linear grammar. Here V1 and V2 are nothing but the variables, and this alpha is nothing but it is a string of terminals. It belongs to sigma star, so it is a string of terminals. Just look at this example. S2A, capital A, B, oblique B. If you look at this production, in this production there is only one variable present, that is capital A, and that is present as the leftmost symbol in this production. Similarly, S2B. The only variable present is the leftmost symbol. After it, we are having alpha. Alpha is nothing but it is sigma star. So alpha sigma star means it is empty, it is epsilon there. Okay. So, but the variable B, it is the leftmost variable present on the in the production. Okay. Similarly, look at the productions of A. It is A to double A, so it is of the form A to V1 to alpha. Variable to a string of terminals only. Okay. And if you will, we look at A to A. So again, here we are looking the finding one variable, that is capital A, but it is present as the leftmost symbol in this particular production. And after this, we are having only the terminals. Okay. And from B to small b, we do not have any variable here. So it is a string of terminals only. So it follows the form V1 to alpha. So all the productions of this grammar follow these rules. If either variable is not present on the right hand side, if variable is present on the right side, that is present as the leftmost symbol, then this grammar is called left linear grammar. So this is the left linear grammar. Now we make a little bit change to it. Okay. Suppose from this alpha we change it to A, and from this V1 we also change it to A, and we say that A is nothing but A belongs to sigma union epsilon. It belongs to sigma union epsilon. Means what this A can be, either it is a terminal because it belongs to sigma, or it can be epsilon. Okay. If such a situation is there, then obviously this form of production is the regular grammar. Here is one variable. On the left hand side, it is a non-terminal and a terminal, or it is only a single terminal. So this is the format of the regular grammars. Okay. So all the regular grammars, if in this format, is called left linear regular grammar. Left linear regular grammar. Is it? So it is called left linear regular grammar. So this is the now we are taking one example of left linear regular grammar. So it is suppose S2 AS oblique BS it is A2, I say it is SA, or it is SB oblique epsilon. So what language? It is a regular grammar, because all the productions are of the form variable to a variable and terminal, variable terminal, and that string of a terminal or epsilon only. So it is a regular grammar. But it is not only the regular grammar, it is left linear regular grammar. It is left linear regular grammar, and the language represented by this grammar is nothing but A plus B asterisk. All words which are possible over A and B. So this is the left linear regular grammar. And here we are looking at that all the variables, if present on the right hand side, these are present as the leftmost symbol. Now the second special type of linear grammar is the right linear grammar. A linear grammar will be said as right linear grammar when the variable on the right hand side, if present, will be the rightmost symbol. Just you look at in the previous definition, we have seen that it should be the leftmost symbol. But if it is not the leftmost symbol, but the rightmost symbol, then the grammar is called right linear grammar. Obviously, as per that, our productions will be of the form V1 to alpha V2. Means on the right hand side, the only variable present is present as the rightmost symbol, and before it there is an alpha, and alpha is what? Alpha is sigma star, the string of terminals only. So either it is epsilon or it is a string of terminals only. And the second format is V1 to alpha. So variable to a string of terminals only. So either there is no variable present as in this production, or if a variable is present, that variable is present as the rightmost symbol in that particular production, then our grammar is called right linear grammar. And we can see the example of the right linear grammar, S2 double B capital B. Okay, so you look at the only variable present is present as the rightmost symbol here. Here we do not have any variable. Here also we are having a variable, but that variable is present as the rightmost symbol. Here we do not have any variable present. So in all the productions of the grammar, either variable is not present, or if variable is present, that variable is present as the rightmost symbol, then grammar is called right linear grammar. As per the last discussion, again, if we change here from alpha to A, means we do not allow a string of terminals here, we allow only a terminal here. Similarly, here also we allow only a terminal, not a string of terminals. So this A will belong to either sigma or it is epsilon. Okay, then our grammar will become regular grammar, and such a regular grammar will be the right linear regular grammar, because if the variable is present, because grammar is regular because it follows the production rules of the regular grammar. In the regular grammar, on the right hand side we have only a single terminal and a single non-terminal, or a single terminal only. So it is a grammar, and in that also, if that non-terminal which is present, that variable, that non-terminal is present as the rightmost symbol, then the grammar is right linear. So that's why such a grammar is called right linear regular grammar. We will just look an example of the right linear regular grammar. It is S2, suppose I say AS oblique BS oblique sigma. So this is a regular grammar. We understand this, and we have written this regular grammar many times, and this grammar represents nothing but the A plus B asterisk. So it is a similar language which we have discussed for the right linear regular grammar. The only difference was in that right linear, in that left linear regular grammar, our non-terminal on the right hand side was present as the leftmost symbol. Here, that non-terminal is present as the rightmost symbol. So that's why it is a right linear regular grammar. So the grammar which we have discussed in the previous example was S2 SA oblique SB oblique epsilon. You can see that both grammars represent the same language, A plus B asterisk. But this is left linear regular grammar, and this is right linear regular grammar. So this is the difference. So both grammars are regular grammars, but because of the presence of the variable either at the leftmost as the leftmost symbol or as the rightmost symbol, grammar becomes left linear or right linear grammar. Another special type of linear grammar is a grammar where the variable on the right hand side, if present, is either at the left end or at the right end, but not necessarily at the same end in all the productions. Is it? In previous two types, we have discussed that left linear grammar, where if variable is present, is always present at the as the leftmost symbol. Then second one was the right linear grammar, where variable if present was present at the rightmost end. Here we allow both. Some of the productions variable may be at the left end. In other productions, variable may be at the right end. So it is a combination of both. Okay, so it is not purely the left linear, it is not purely the right linear. So, but we allow such a combination. So it is also another special type, and the beauty of this special type is that every linear grammar can be converted to this form without affecting the language of it. So by inserting the new variables, how we will be doing it? We will be doing it through the insertion of new variables. Through one example, we will look at how we can do this. But what we will do, we will insert some new variables to convert a linear grammar into this particular form. So every linear grammar can be converted into this form by introduction of new variables. Now we'll take one example for it. Now in this example, our example is the first one which we have taken for the linear grammar, S2 ASB oblique epsilon. And the language represented was A to the power I, B to the power I, such that I greater than equal to 0. Now we will convert this linear grammar into our third form. Okay, so what we'll do, we will write S2. Here A is the starting, so we will start with A, and then we will follow it with a variable A. So we have introduced a new variable A. Now A should replace what? A should replace this SB, because first A we have taken here, then this variable A should generate capital S and small b. Okay, and here we do not have any variable, so this will come as it is. Okay, now for A, what we will be writing? We will be writing SB. Is it? So if we consider this particular grammar, then also we will be generating the same language, because whenever we are at S, we will be generating an A, then we will change the variable from S to A. We will come to A, and then this A will generate S again and a B. So corresponding to each A, one B will be generated, and S will remain in between those two terminals A and B. So again we are having S, again we can use S for A, small a, capital A. So one more A is generated, and then this capital A will again generate this capital S and A small b. So the corresponding B is generated and S is there. So whenever we have to remove S, we have to convert our string to a string of terminals only. We are bound to use this S to epsilon. So through this we will be converting our working string into a string of terminals only, and thereby generating the same language A to the power I, B to the power I greater than equal to 0. So the language where number of A's and number of B's are exactly the same. So same language has been generated. So language is not affected. But if you look at this type of the grammar, it is a linear grammar, because on the right hand side in each production, if variable is present, that is present either on the left hand side, or either on the right hand side or on the left hand side. But only one variable is present. So as one variable is present, the grammar is linear grammar. When variable is present on the right hand side, this may form a right linear grammar. When variable is present on the left hand side, it may form a left linear grammar. But this should be true for all the productions. So it is not true for all the productions. So it is a hybrid of linear, left linear and right linear grammar. So this form we can convert. Every linear grammar can be converted into this particular form. Is it? So our regular grammars will be either will be having the productions of either this form or this form. So we can say, we can conclude that all the regular grammar are linear grammar, because they will be having either the productions variable to a terminal only, or the epsilon, or they will be having the production of the form of this particular form where the only variable present is at the right hand side, or of this form where the only variable present will be at the left hand side. Okay, so all regular grammars are linear grammar.